started?
Yeah.
Yeah, okay. All right. So again, we've talked about this yesterday. Ada, can you sit from them?
Yeah.
No, you can sit there. So again, correlation talks about relationship. Are they related or not? Like we said yesterday. So if you want to talk about the relationship between variable x and y, we are going to describe it using some characteristics. Then people can understand fully what you're saying. Okay? Oh, is there a linear relationship or not? It's just like saying, is the equation between the function y and the variable x, is it linear? Is it quadratic? Is it cubic? Is it exponential? Is it logarithmic? That's what we are saying. Is that understood? If it is not, is it a linear or non-linear? The non-linear are in the categories of either exponential or logarithmic or whatever. Young man, I'm going to stop you from leaving my class to get water because it takes you forever most times. So we're going to have different types of relationship like that. Linear or non-linear. Non-linear can be so many things. Okay? But here, you don't have to worry about what do we mean by non-linear. Nobody cares. And for IB, like I said, it's all about just linear. So these two characteristics, these 5 characteristics, tells us so much about, give us more details. That's why they are the characteristics of the relationship. The direction. Is it positive, is it negative, or is it no direction? Okay? Positive means when one increase, the other increase. Negative means when one increase, the other decrease. No correlation means they're not even related. Linearity. Then let's go here. Talk about the strength. Be it positive or negative, how strong is this connection between them? Okay? This is the main thing we want to study next with something called correlation coefficients. Even by this strong, how strong is this strong we're talking about? Am I making sense? But in general, we have strong, moderate, or weak for positive and negative. We talked about this yesterday. Okay? Outlier. If it does not follow the trend of the data, it's an outlier. But I was telling you yesterday about the general statistics, because usually I taught these statistics, I taught that statistic before this, so it was easy to connect for the Form 6. We talk about outlier as being that data that is far away from every other one. Okay, we have a test, and we are all in 50/70, and Jensen got 69. His score is an outlier. Or maybe I got 5. Then my score is an outlier. Because I'm supposed to, everybody clusters around the mean. But you are just far away, either on either side. But that's not the scenario here. Okay? We are not talking about clustering around every other data. We are saying, okay, it doesn't follow the trend. It's like the black sheep of the family. Does this make sense? And then that's an outlier. So I've given 4 examples here. We have 2 data that seems to be far away, even though this is not so far away. C seems to be far away, but it still follows the trend. But these 2 do not follow the trend, so they are the outliers. Understood? And finally, the causation. Is there a causation or a causal relationship between these 2 variables that you have found to be related? Because if they are related, does it mean one causes the other? Elsie, you have 2 options. Does it mean one causes the other? Okay? If one causes the other, then yes, you have a causal relationship. And we've talked about the arm length and running speed or something yesterday, right? The fact that people with stronger arms, longer arms, tend to be either running faster, doesn't mean the length of your arm actually causes the speed. We talked about that yesterday. That what was responsible, even though there's a correlation, you can see that, oh, when the arm is longer, maybe the running speed will be longer. We see there is a correlation. But it doesn't mean that the speed is caused by the arm or the arm is caused by the speed. But we're able to see that, actually, both of them are related to the age. And that is why it looks like they are causing, there's a causal relationship, but there's no causal relationship. even though both of them are correlated. Okay? So if you have that causal relationship where one causes the other, then you can now talk about the dependent and independent variable. Okay? The dependent variable, just think of your y is equal to mx plus c. Y depends on x. That's the easiest way to think about it. When somebody says find the value of y, it depends on whatever x you bring in. Okay? So this is your independent variable. You just assume anything you want, Miss Independent. Or Mr. Independent. Nobody can tell me what to do. Right? But you are the one telling y what to do. So y is the dependent. Is that clear? But in a more general term, is the explanatory variable and the response variable. Y will respond to x. X is the explanatory variable. Does that make sense? And this is where we stopped yesterday. So, in addition to what we have seen so far, no. I just want to take this. In addition to what we have seen so far, when discussing the strengths, how strong is the strong? How weak is the weak? How moderate is the moderate? So there is a mathematical, a numerical value to actually tell us the strength. For example, the correlation between, or let me say the relation, let's use the word relationship now. We found the numerical relationship, the value, or relationship between Anika and Denise to be 0.8. But between Anika and Melody to be 0.95. This is Anika and Melody. This is Anika and Denise. If you are picking besties, who do you pick? Speak louder, please.
Anika and Melody.
Speak, everybody, please.
Anika and Melody.
Because they have a higher correlation coefficient. Even though both are pretty strong. So it's like the saying of, oh, we are besties, but actually, some besties are better than some besties. Or let's say some besties are best than some besties. You get what I mean? That is what the correlation coefficient does. It gives you that numerical value. And then you can measure and say, oh, actually, compared to that, this is what happens. But this is just broader terms. Strong, weak, moderate. But even on the scale, how strong is your strong? How weak is your weak? How moderate is your moderate? Your correlation coefficient is between -1 and 1, with both ends called perfect. Perfectly strong if it is 1. Perfectly strong or negative if it is -1. And in between, then you have some other ones. Just like your probability. Highly likely, likely, very highly likely. You get what I mean? On the probability scale, we have something like that also on the correlation coefficient. To compute that, we use something called Passing product moment correlation formula. No need to memorize this, it's in your formula booklet.
Oh, nice.
And your calculator has a function to be able to do it. And that's we're going to practice as well. Okay, but let's write something about that first. Let's write. Person's product moment correlation. Product moment correlation. You know, you guys are so lucky. Back in the days, we do this manually. You don't have a calculator function. So you use the formula, you might get one part of the table wrong, you're finished. Not like finishing. Now, the reason why this is important is because when you look at the data, it depends on you. You can say it is very strong. Somebody can just say it is strong. So it's based on opinion. All right? But in a more general way, more fair way to judge is using the correlation coefficient. You cannot say my 0.9 is your 0.8. It has to be the same 0.9. But if you look at the picture, the way you see the picture might be different from the way I see the picture. All right? That is why just looking at the scatter diagram and concluding very strong or not very strong, it depends on who is looking at it. So, but this is a more broader way to look at it. Okay, so let's try. Since the interpretation of the strength of correlation using the scatter plots, or let's say from the scatter plots, which one is better? From scatter plots. Is subjective as it relies on the observer. That's what we have just mentioned. It depends on what you think. Okay? A more precise way to determine the measure of strength is by the person's product moments correlation coefficient. So, our data is always in two forms, right? X and Y. Talk to me, please.
Yes.
Because it's bivariate data. So, they are points on the XY plane. So, let's put it this way. Given the set of data x1, y1, x2, y2, up to xn, yn. Maybe I put the letter R here already, so I don't have to write so much. Small letter R. Okay. R is given by here you have square roots, summation xi minus x bar all squared multiplied by summation yi minus y bar all squared, and this is summation xi minus x bar yi minus y, where x bar is mean of xi and y bar is the mean of yi. So basically summation x over n. Y bar is summation y. I believe some of these symbols are not supposed to be straight to you. Have you heard of x bar and y bar before? Don't tell me no. When I taught the statistics in IGCSE, I must have given you that notation, and I said you meet it later in IB. Even though IGCSE does not require that notation, welcome to IB, where the language has to be spoken, the way it should be spoken. Not Chinese language, but Chinese language. Okay. So when we say something bar, if you say P bar, it simply means the average of all the P's. Am I making sense? When you say Q bar, it means the average of all the Q's. When we say average, we're talking about arithmetic mean. Because later you will realize that there are 3 averages actually that we study. The mean, median, and the mode. They are all averages. But in primary, when they tell us find the average of 2 numbers, we just find the mean. You understand? Find the average of 3 numbers, we just find you had them together divided by 3. But that's not the only average. Okay? So in a standard examination or higher, classes like this, if I wanted to find an average, I'll put in bracket which of the averages. Because otherwise, you have the right to sue me if I mark you wrong. Do you understand that? So find the average in bracket mean of the following data. Because your average could be, if you want to be lazy and I say find the average and you see the mode is the easiest, right? Just pick which one is appear more, right? I just say, oh, average is 2. Hey, but you didn't find the mean. Oh, boss, you said average. And I just pick 1. Am I making sense?
Yeah.
So when we talk about x bar, we're talking about that average mean. So again, the same letter, if it is t bar, this means summation of all the t's. Maybe you are talking about the average time. Summation of all the time divided by how many times you have added together. So that's the symbol for mean. Okay? But again, we don't need to memorize it. It's in our formula booklet, I think, but then it's in our calculator. Calculator is expected to be used, not memorizing and doing something manually. This is not a manual generation anymore. Our parents had the manual generation. Now, there is an interpretation to this. I'm going to write that next. But before then, bring out the calculator. Projector on, please.
Oh, sorry.
Miss Kadina. Silence, please. Focus. Let's see if we have it in our formula booklet. Okay, it's not there. I guess because in the calculator already. All right. So we're going to find the correlation coefficient. Uh-oh. Okay. We're going to find the correlation coefficient of this data. Please, I need full attention here. So the data, this is x and this is y. Okay? I think we might do something too. Maybe we should also try to do this manually and see if we have time later. So the first thing I want you to do is take your calculator and go to statistics. Are you there yet? Let me follow you, please. Statistics. Then you will see the list, right? So put x in list 1 and y in list 2. Okay, I have some stuff in the list I need to delete. Okay, 2, 5, right? 6, 3, 9. Got it. Then for the y, do the same. You can follow the instruction and just continue on your own. Try to figure out my life on the calculator. So once all the data are entered, everything ends at data 5, right? So data 6 and the rest will be empty. Then go to calculate, which is F2, F6 for setup. Okay. This particular one is very important for us later. We'll talk about it, but for now, don't change anything, right? Two variable, okay, wait. For the two variable, you need to make sure the X list is list 1. Is it?
Yes. Yes.
Because in mine, it is currently list 2 because I did something called regression of Y and X. So I'm going to change this, list 1, and this will be list 2. So now let me explain what you are saying on that list. Go to that list screen again, everybody. One variable X list, you're talking about a data that involves only one variable. So maybe, oh, this data contains X, and maybe the frequency, something like that. Okay, even that X will be a second list anyway. So one variable, like a univariate data, not bivariate data. But here, you're having two different data. Maybe hours spent on the line and grade of IB, something like that. So two data relating to, it could be student 1, student 2, student 3, student 4, student 5. So you see that we skipped one variable X list and one variable frequency, right? Later we will come to them. If we are doing frequency distribution table, we will specify here that, oh, actually, list 1 is the data. Then one variable frequency is list 2. We will change that later. But for now, your focus is on two variable X list, two variable Y list. Frequency 1 means each data appears once. Do you understand? So you don't need to touch that. Just leave it by default. So after you set that, and the next thing is to go to regression. Okay, no, we're not doing regression. We're calculating the correlation coefficient. Oh yeah, it will calculate automatically. Regression, X, then AX plus B, and you can see the correlation coefficient. All you need to pick is the R. We'll talk about the rest later. Okay, that R value is minus what? 0.8589. So this is how you calculate your correlation coefficient. This is what the formula does for you. But because in one of the exercises that I'm giving you today, I want you to see how it is done manually as well. You never can tell what happened in the university. But I think I put it for a question or two, for 2 questions. The rest, you just use calculator directly. Understand? So, for what I expect you to do, I've also drawn the table. We're going to do this particular question because they are just few, using this, formal way of doing it. Is that understood? We'll do that together now. Maybe I take a picture of this board first before we take it off. You said something?
Did you write something in here?
No, we're going to have to move there. Okay. So, if we were to do this manually, your calculator will also be used. X and Y. So you have 5 data. 3, 4, 5. Okay, so what are the information? Yes, X, 2, 5, yes.
6.
Speak louder, please.
639.
Why?
11, 6,
Why is Rita quiet? Imagine everyone is quiet. So don't say, oh, people are responding already. I don't need to. Yes?
11, 6, 4, 6, 3.
Now, what you put in your table depends on what the formula looks like. The formula says R is summation of xi minus x bar, right? Yi minus y bar, right?
Yes.
And everything divided by the square root of the summation of, what is this one again? Xi
minus x bar
all squared, yes. Then summation yi minus y bar all squared. I hope you know what yi xi means. So why didn't you say something? Anyone? What does xi mean? Anika? What do we mean by? I've explained what x bar means, right? What? Can anybody remember what x bar is?
X bar.
Yeah, x bar.
Oh, the mean.
The mean of all what?
Mean of all x.
Of all x. Anika, that was the moment ago. Please. This is why you should participate. If you participate when I'm talking, you should remember. Not just copy, go. So what does xi mean? Melody. Try. Say that again. Initial, not really. Yanko. Some. So what does this sigma mean then?
I don't know.
Rita? For you? Really? I used this notation in the past. Xi. I changes value. I could be 1, 2, 3, 4, 5. What does that tell you? Come on, just think. I could be 1 to anything. Look at my notation there. Look at the first paragraph. What did I write? The first paragraph in black. What did I write there? I wrote N. The last paragraph and the last place there.
Given the set of data x1, y1, x2, y2.
So what does xi mean then? Ryan, don't sleep in the class, or I ask you to leave the class. Yes?
Sets of data.
The data. Xi is all this, and these are the yi's. Come on, this is notation. This is trivia things. I'm sure I've mentioned it also in Form 4. We use it in coordinate geometry. Changing x over changing y, we write y2, y1. We use this index to tell us different points. And because it's correlation, you think it means something different. Mathematics is consistent. 2 plus 4 cannot be 6 in P6, and 2 plus 4 is now 8 in Form 1. Okay, so basically this means we're going to add the difference between x and x bar. And we don't even know what x bar is. So that's the first thing you're going to find out. X bar is summation x divided by n. Yes?
Yep.
So find the summation n for me, please.
25.
Say that again.
25.
Summation y.
30.
So it means x bar is 5 and y bar is 6. So then we can start talking about this. So I need the difference between each x and x bar. Xi minus x bar, which is more or less xi minus 5. Yes?
Yeah.
You don't need to show this. Just say it. Again, yi minus y bar. It means I need them multiplied. So I'm going to do xi minus x bar multiplying by yi minus y bar. Okay?